So one of the strategies for finding a limit as x goes to a value is to try to simplify the expression first. So let's take a look at h of x, and let's factor the numerator, well that's already factored, and the denominator. X squared minus x minus 12 factors into x minus 4 times x plus 3. And here we can see there are two discontinuities here. One at x equals 4 and another at x equals negative 3. But we can kind of simplify the function by dividing x minus 4 divided by x minus 4 to 1, and I get 1 over x plus 3. But we still have the caveat on here, x can't be 4, right? Because in this particular case, h of x, if we just look at the original formula for h of x, x can't be 4. So even if we simplify it, we still don't want x to be equal 4. So what happens to the limit as x goes to 4 on h of x? Well, we can do this one. It's the limit as x goes to 4 on 1 over x plus 3, the simplified version. Now, we know x can't be 4, but remember, a limit is not the same as a function value. So to evaluate this, because this part is now continuous at 4, this is just going to be 1 over 4 plus 3, which is 1/7. And if you look at the graph, if you go to x equals 4 on your graphing calculator on Desmos, you will see that there's actually a hole in the graph there. But if you get very close to x equals 4 from either side, the hole happens to be at the point 4 comma 1/7. What if we wanted to do the limit as x goes to negative 3? Here again, we can do some sign analysis like we did in the last problem. So we're going to look at the limit as x goes to negative 3 on 1 over x plus 3. And we can see that if x is close to negative 3 from the right, in other words, it's a little bit bigger than negative 3. When we add 3, we're going to get a positive number, and we're going to get 1 divided by a positive number, which is going to head off toward infinity. And the limit as x goes to negative 3 from the left, here we're going to have a negative number that's further away from 0 than negative 3. Plus 3 is still going to be negative. 1 divided by a negative number is going to be negative infinity. Since the limit from the right and the limit from the left are different, we know that this one does not exist. Let's take a look at j of x. Here again, we can do the same sign analysis by simplifying a little bit. Let's simplify j of x to x plus 2 over, if we factor the denominator, that's x plus 3 squared. If we want the limit as x goes to infinity, as x goes to negative 3, we know there's an asymptote there, so we've got to figure out which way it goes along the asymptote on x plus 2 over x plus 3 squared. Let's think about the left limit. The limit as x goes to 3 from the left, negative 3 from the left. Negative 3 plus 2, something close to negative 3 plus 2 is going to be negative. And something close to negative 3 plus 3 is still going to be negative. Squared, though, is going to be positive, so we get negative over positive. So this one is going to be negative infinity. And the limit as x goes to negative 3 from the right, let's see, negative 3 from the right plus 2 is still going to be negative, and the denominator, negative 3 plus 3, is a positive number. Something close to negative 3 plus 3 is positive, because I'm adding on more. Squared is still positive, so negative divided by positive is still negative, so that's going to negative infinity. So this guy is negative infinity. We need to check both the left and right limits on those.